So hi guys, so I'm today going to explain the router architecture. So we are mostly working in the configuration. So how the configuration from the UI goes to the backend and the changes are made, I will explain. So first, let us see there is an LAN. So let us take an example. So for example, if I want to change the port settings, I'm going to change the link speed. So this is the speed of the Ethernet. So I'm just downing it to 100 Mbps. So to make it, I will just apply, but in the back end I don't know how it works. So for that, if I apply, the setting is applied successfully will be the UI prompt. So let us inspect which is called. So for example, I make it as auto negotiation and I will just open the network here. Okay. So if I just apply, so you can see JSON is sent to the router, and with that JSON format it does the job. So for example, here the parameters are LAN1. Since we are changing the LAN1, so the entire parameters are sent to the router. So LAN1, the support EEE, these are all the fields in the changes. Okay, so now we are just changing in the UI. Now we can see how it goes to the backend. So here in the headers you can see socket communication is our CGA. So so web browser, in our web browser if we change port setting, now let us see how it changes. So for example, here we are changing the port settings, for example link speed, and then we are clicking apply. So here the JSON RPC will come to this light TPD socket communication. So light TPD is a lightweight server which runs on the router on port 80 and port 443. So for HTTP it is 80 and for HTTPS it is 443. So when a JSON comes to the light TPD, it sees its CGA. So it maps the CGA whether it has multiple CGAs. So it checks whether which CGA is. If it is socket communication, it runs the CGA script of socket communication. So now what the CGA script will does is it will there is a C file called socket communication. So for that it will fork that process and it will set the environment variables and it will give the parameters in the standard input as a standard input. Now the socket communication has the data. Now it is a process in the user space. Now it wants to give the data to the gfconfig, which is another process running on the user space. Now for that, so inter-process communication we need. So for that they have used Unix domain socket. So Unix domain socket is used to pass the data from socket communication.c to gfconfig. So here also again the JSON format will be made and then it will send to the gfconfig. Now gfconfig is then it has an RPC handler. So it will JSON RPC handler. So from the JSON RPC which the gfconfig gets, it checks so in the JSON object we have the methods and the parameters. So to check for it will have all the set of methods in one file. It will check whether the method is present. If present, it will call the method with that parameters. So so here why we need UCI means, so since the config files are written in UCI format, so why config files? So for example, if you do some changes and if you reboot the device, so the changes should be there. So if it goes when you reboot, then it is not recommendable. So for that they will store the configuration in the /etc/config, so in the UCI format. So for that there is a library called libuci. So in the C program with the libuci library, they will write the content to the config file and then they will restart the particular daemon. So for example, if I made the changes for the network, then I will reload the NetIFT. So if I made the changes for the DNS mask, I will reload the DNS mask. So the UCI format will be written and it will manually restart the daemon. So here why procd? So procd is the process which is started at first in OpenWRT, which forks all which starts all the daemon. So for example, while starting the daemon, we will do this slash etc slash init.d slash the daemon name and start. So it does so while you reboot the device, procd starts all the daemon. So how it start means, so we will write all the service file in the slash etc slash initd, and then I will write the service file. So it will start the all the services which are in the init.d folder. So once procd will restart all this. So procd will restart. So for that a ubus will be there. So with the ubus is a microbus, so which is a public subscriber model where if anyone want to do if anyone want to make some changes in some of the public, so they will send a message. So the ubus daemon will listen to that, and it will say that you have some changes, and then the particular daemon will respond to that. So for reloading the network service, we will reload the NetIFT. So insight agent, SNMP agent and engage agents. So why we need insight agent? Because, so for example, here the web browser is only reachable when we are in the LAN. So every time we can't be in the LAN. So for if you are in somewhere in the remote and we need to change the configuration of our router, we will use the insight agent. So here insight agent, so we will onboard the device to the insight, and with they will keep on, there will be a polling mechanism where the router insight agent will keep on polling whether any changes are made. So and then if any changes are made, it will reflect back in the router. This is based on insight agent. So hardware watchdog is like when a device so if something happens and the device is not properly functioning. So for example, how a watchdog works is, so there will be a function which will be calling the calling the watchdog periodically. So if the periodical call doesn't happen, so watchdog will reboot the device. So this is the hardware watchdog. So thank you.